One of the tools that I use all the time when I need to make the choice about how to represent my data visually is this hierarchy of visual forms, or graphic forms, that was created by William Cleveland and Robert McGill in the 80s. So this is my own version of that scale. Cleveland and McGill scale looks a little bit different, but the structure is essentially the same. So I showcase this scale, by the way, in both my books, The Functional Art and The Truthful Art, just because I believe that it's so useful. So let me explain how Cleveland and McGill came up with this scale. What they did was to conduct a series of experiments back in the 80s, encoding data numbers onto spatial forms, like or spatial properties. For instance, they began with three different numbers, let's say 70, 35, and 10, or something like that, and they encoded those numbers using a bar graph and a bubble graph and a pie chart and a series of shades of color of different intensities, etc., etc., etc. And then they asked the people participating in those studies to estimate the relative sizes of those numbers using the graphics as to make that estimate, right? And they discovered that it is possible to create a hierarchy of graphic forms according to how accurate the judgments are that you can make with those graphic forms. This means that the graphic forms that belong to the top of the scale, these ones over here, for instance, the bar graph and the pie chart, sorry, not the pie chart, right? That comes later. The bar chart, the dot plot, the line chart, etc. And the dot plot, which is or the dot chart, which is something that Cleveland himself advocates for because it's a very useful graphic form. Graphic forms basically that are based on graphs, that are based on common scales, and that have a position along common scales, the position of an object along common scales, as the main cue to identify or to calculate or to estimate the numbers. Those are the ones that allow for most accurate judgment. So whenever we need to make a graphic with the goal of making accurate estimates, we should try to go up in the scale as much as possible. If it is possible, go to the upper portion of the scale. There are many other graphic forms that use both the size of objects and the position of objects to codify, to encode the information. For instance, in the past few years, many people, such as, for example, Stephen Few, who has written several books about data visualization, have come up with new graphic forms, have expanded the vocabulary of data visualization. Steve Few, for example, invented this graphic form that you have on screen right now, the bullet graph or the bullet chart, which is a variation of the bar graph. It summarizes a lot of information in a very small space. For instance, you can compare one metric, your revenue or your profits, and that is encoded with the bar, right, to some sort of comparative measure, which could be, I don't know, a target or your performance last year. And then you can compare those two things to several ranges of performance, like bad performance, average performance, and good performance, right? So imagine trying to show all these with a regular bar graph. You will need at least 5 bars per metric, right? What the bullet graph does, or bullet chart does really, really well, is to condense all that into a very small space. So you can show a lot of information, like revenue, profits, order size, etc., in a very small area. Well, anyway, I mean, this uses a method of encoding, methods of encoding that belong to the top of William Cleveland and Robert McGill scale, because it is using methods of encoding such as length, but also position along common scales. So they enable very, very, very accurate judgments.